and therefore you have this kind of effect. Okay, so you can see from here you have the the S printed part, which is then attached to the building plate here. So you see that this is the part here, and if the part is aligned more or less 45 degrees with respect to the horizontal plane, you can see here. So without the support structure, the part cannot stand like this for sure. So you need some kind of support structures. You can print the part horizontally. So lay the part on the lay down the part on the building plate. It's okay, but you know the properties of the part in different directions will be different. So probably they have already calculated via several tools and point out that this is the preferred direction for printing out, and therefore they create that things. And the alignment of the part or the orientation of the part with respect to the horizontal plane also affect the amount of support that need to create for the printing process. So you will learn this probably chapter 6. And after printing process, you have more or less like this. You need to eliminate the residual powder. You need to cut the part and the support structure from the building plate. You may need to polish the building plate for the subsequent use. You need to eliminate the support structure from the part for sure. Yeah, and you may polish the surface of the part if it is required. Yeah, and here on the right side you have another figure, also showing you the support structures which is then attached to the part and to the building plate. Yeah, and these, yeah, waste, to be honest. So what you need to do is to minimize the support structures, but not in all case. Not in all cases you need the support structures. The fact is that because you can design the part which is self-supported, they can support itself. Yeah, there's structure like this. There are structure like this. So what we need to do as engineers, so we need to design so that we can minimize the support. We need to select the orientation of the parts with respect to the building plate so that we can minimize the support structure, minimize the amount of support structure. And usually by using the software like Additive Designer for SLM machines or Materialize or Autodesk Net 5. So there are some names of the software that can be used to process the model before they can be printed out. So this allows you to optimize one of the three parameters. The first is the building time. The second is the amount of support. The third is the degree of distortion of the part after the 3D printing process. So the diagram is like a triangle. That. So whether you select one point, so you may optimize one of the three criteria that I have mentioned. So building time, amount of support structures, and the degree of distortion that may occur for the part. So we do not want large distortion after the after the printing process, of course, but we also do not want to prolong the building time. We do not want also to increase the amount of support for sure, because it's waste of material. But life is a life. You can optimize normally one criteria at a time. So that's you need to balance. That you need to study. Yes, it depends. Okay. Yes, my my energy is almost 1 hour because I have a strong feeling that I am speaking more frequently than I used to when I'm deliver the lecture at class. Because at class, you and an audience and student of the course has have opportunities to discuss with me, to raise your voice. But for the moment, it is one way transferring the idea, the knowledge, and so on. That could be the reason that I speak more than I used to, and I lost energies rapidly. Okay, okay, okay. So I think that I will continue with these lines, or probably half of this line, and we can stop here today. According to the message of Tung said that he will, let's say, prepare the list, but it would be better if I could check also, and we have two lists, and we can double check here about the attendance of the student today. So because it's basically this my responsibility. Yeah, this is not the responsibility of the monitor or the vice monitor. This is my responsibility. But don't help me. Yeah, thank you for that. But then I would like to check also. So it takes a little bit of time. Just let me see. Yeah, yeah, yeah. At home, I use my laptop, but when I'm at class, I use my son's laptop, which is prepared for him for learning online. But now the pandemic almost ends or is ended already. Nobody knows. I feel more confident by using my laptop. It's okay, just for fun. Okay. General AM process. Uh, process is includes several steps, which we turn. Where's my phone? Sorry. Okay. Returning the CAD model into the physical object. So typically, it includes 8 steps, as you can see from the right sections of the slide. And for the large, okay, for the simple products, um, and for the simple process as well, we will use the AMs for simply for visualization, just to see. But you know that for the moment, AM can be used for fabricating different parts that can be practically used for real situations. For example, as you can see from here, the 3D printed at the bottom of this line, the 3D printed GE General Electric company is quite famous company in the world. Aircraft engine bracket, and this can be used practically. And this figure is taken from a journal paper, and you can click on the DOI and you can see the paper. So, yeah. Okay, I will come back later to this figure, but let's continue with the bullet points. But larger and complex products is may contain more stages and iterations via development process, because you know that for the traditional manufacturing or traditional design, or come on, for the traditional product development process normally is rely on the trial and error approach. So it's typically be costly and time consuming. Why? Because it's a trial and error. So they try to create a design, and after the designing process, they fabricate the part and they test both virtually via the software and practically via the experiment. And if they see that these cannot be used, and then they throw them away. So it's waste of cost and time. It's a matter of money. So it's it's not reasonable, yeah, for the moment, because people tend to check virtually before it can be subject to the next state of fabrication. So in the company, the most important point is uh, the benefit, the money. They want to receive the money. They do not want to invest to something that cannot bring back to them money. So when you graduate and you work for a company, and you will understand properly that point. And yeah, and for the large and complex products, and I have mentioned to you that after the 3D printing process, you may have to deal with the complex post-processing processes. This may include the heat treatment for stress release, the heat treatment to obtain the desired mechanical properties of the material. Is may include the elimination of the support structures, the uh, the separation of the part from the support structures and from the building plate. Is may combine with the hot isostatic pressing to increase the density up to 100% relative density. And yes, you can see that. Yeah, it can be a single phase in order to create the prototype for visualization only, or with large complex product. Product is not the prototype, but it's the product. It can be used practically, and it may contain stage and iteration. So yeah, because the product development is not a single uh, process. You can go back to improve some feature, fabricate, testing, and so on, and come back. Is the is maybe content of several iterations. Yes. So it's happen normally. Yes. In order to optimize parameters or optimize feature of the part. And most of AM processes contain 8 steps, as you could see, and at least in a rectangle, or in this square. And okay, I just highlight just 8 point in this square, and then you will be free for my lecture today. The cat, yeah. Initially, you need to create the cat model. So this can be done either by using Inventor and starting from the sketch to draw the 2D, and then you extrude. For example, this is the extrusion. You can use the loaf, yeah, whatever it is. So you can use the rotation. So for example, if you want to create something like this, so you create a sketch, this sketch, which is like the cross section of this, the how can I say this shape, but it's just on the cross section. You select the center line and you rotate the cross section around the center line, and then you have the shape around shape, surrounding shape of this cup without even with the bottom of the cup. So it's simply like this. So you have the cup without the handle, and then you convert the 3D solid model to the STL model, and I have already mentioned to you that this is the surface model or the faces model, and you will have something to do with the STL conversion, because normally the conversion set has some issue, and then you need to repair the model, and then you need to transfer the file to the machines, because inside the machine also has a kind of control software, and you have to play a little bit with this about the arrangement of the part with respect to the building substrate, the orientation of the part, generation of support, selection of the printing parameters, and so on, and anything which make the motor to be ready for the printing process. So that you need to do. And then the machine setup, okay, some kind of calibration, some kind of consideration of material, is stock, whether you have the power which is ready for the print or not, electrical power, and what else, or whatever. Machine setup, okay, you need to set up everything. Of course, it will be introduced in the manual instructions, but not here. Yeah, the technician will know how to do it. But of course, it is better if you know. The building process, yeah, this happens for the build, and then remove. It means that after you build up the part, you you collect all the residual powders. Uh, you need to remove the part from the building substrate. You may perform heat treatment before that. And post process, yeah. You mean to cut the part from the building plate, cut the part from the support structures, and you may perform hot isostatic pressing and so on. It depends on the requirements of the quality and the properties of the parts. And finally, the application. And need to test, to verify the design, to validate the design, to get some kind of approval from the administration, like the Federation Aviation Administration called FAA in the US, and before you can apply it, use it in the airplane. I think it's enough for today, and thank you for your attention. Now you are free for the course, but I'm still there in order to check your attendance based on the message. And thank you, and see you next time. Why is it stop sharing? And yeah, thank you. Mute and turn off my screen, turn off my camera, and you are free for now.